Hey guys, this example is a square-based pyramid. We're going to start off by drawing a picture of a square-based pyramid, and I always begin with an oval, sort of like the oval at the bottom of a cylinder or cone. Now, I draw it a little angled. It's pretty good like that because I don't want any 2 points directly horizontal from one another or vertical from one another. I want it to be a little off, you know? So if I go right here, it's going to be right next to this one, and I don't quite want that. So a little higher, a little lower. Okay. From the center, really I should have plotted the center point before the dots, because when you put the height up, you don't want your edges to overlap each other if you could help it, and you want to be able to really see them, you know? And we go from this apex to each of the vertices. Don't really love that this lined up where the height passes through that back edge, but it's what you get for not carefully planning. And we drew our square-based pyramid. Now, if it's a square-based pyramid, all of these edges are going to have the same length, but really, you could apply this logic to any regular polygon. This line through the center of one of the triangular faces is known as S for the slant height. Now, this is not actually a square-based pyramid if you look closely. This is actually a rectangular-based pyramid, but we're going to use the same logic and the same types of formulas here to figure out the surface area and volume of a rectangular based pyramid. So let's get started. I'm going to write my surface area equation more generalized so it will apply to a rectangular base pyramid instead. B squared represented the area of this base. If you have a rectangle instead of a square, you may call it length and width instead of B and B. So your area of your base is no longer B squared, but it's L times W plus 2BS stands for 2 base times slant height. This is the 4 triangles. This comes from 1/2 base times slant height for all 4 of the triangles since they're identical. In this case, they won't be identical. You'll have 2 identical triangles here and 2 here. The way we change our equation is slant height is going to be slightly different on each triangular face. So what I'm going to do is I'm going to call this one slant 1, and I'm going to call this one slant 2. We'll have 2 times 1/2 times width times slant height, plus another 2 times 1/2 length times S1. 2 times 1/2 is 1. So surface area equals length times width plus width times slant height plus length times the other slant height. As for the volume, it's going to be quite similar. The volume is still going to equal 1/3 area of the base times the height. 1/3, the area of the base is LW times the height, which can still be H. Now, if we did the example, how would we figure out each of these slant heights? If this side is 5 and this is 2.5, if this is 11 and this is 2.5, how can we figure out the slant height right over here? We could do a Pythagorean theorem. Now, I'm just going to go ahead and put this in a calculator and figure this out. This line will represent the other slant height. If this whole entire side here is 18, that means the length of this is 9, and that's still 11. So we're going to do Pythagorean theorem again. So this one is 14.2 approximately, and that one there was 11.3 approximately. So if I want the area of this triangular face, all I need to do is 1/2 base times height, with the base being 18 and the height being 11.3. This triangular face is identical to the one behind it, so that will be doubled. So instead of doing 1/2 of this base times height, you can just do base times height. Same with this triangle over here, the more narrow one. I could just go ahead and do 1/2 base times height, or base times height, since I have another one identical to it right back there. So 5 times 14.2. So 5 times 14.2. Then we'll add those 4 triangles to the area of the base. So here I'm just going to do 5 times 14.2 since we just saw how the 2 and that 1/2 reduced down to a 1 anyway. So the surface area is approximately 364.4 inches squared. And now let's go for the volume. Area of the base is 5 times 18 times that height, so the volume is 330 inches cubed. I hope this little mini lesson helps you understand the volume and surface area of pyramids that may have a square base or even a rectangular base. And I hope you even see the logic and how this really could apply to a pyramid with really any polygon as the base. Good luck!